That's right.
Barbara, I have you on twice.
Thank you.
Yeah, so you want to get rid of one of them or else you're going to get that big echo.
Just once now?
Yep, that sounds great. Excellent. I'll go down and make sure everybody can hear.
This is for my daughter, Elena Antoniadis.
Oh, great, great. Okay, well, I'll say hello to all of you guys. I'm going to just unmute you for a moment while we're waiting for everybody else. So I've unmuted everybody. Wanted to welcome you all. How is everyone doing?
She's starting early.
Oh, no, I'm not starting early. I'm just chatting while you guys are here.
Oh, she's just chatting.
Hi.
Yeah.
I think she responded to me.
Just saying hi. Anybody have any particular questions before we do start exactly at 11? No questions. Okay.
Well, one question is we noticed there was a biology and biochemistry segment. Is that there's no chemistry segment later? Is that correct?
That's, as far as I know, that's correct. If it's not shown up on your invitation screen, then they're not having a separate one. But you can always look at the website and try and contact the undergraduate advisor. And if you have any problems with that, let me know. Just send me an email and I'll be happy to help you in that.
Great.
Does this one cover health sciences?
Well, you know, there's an interesting thing. It does not cover health sciences, but for people who plan to go, for example, to medical school, it turns out that they're going to have to major in a science anyway. So the medical schools really love to see research. So this is very relevant for people who are interested in going to medical school, not so much if someone wants to go into physical therapy, for example.
Okay. Would this be the tour the session closest to somebody who wants to become a PA?
You know, again, the way I view these things is that unless there's a conflicting one that you feel you want to go to, you can, what I'm going to try to cover is something that every student really ought to know who's going to even take science classes and be interested in. This gives a student option. You know, many of the students come in and they say, oh, I'm such and such, because they've not had a chance to be exposed to other things. So my recommendation is, unless you have a conflict, listen and decide.
My name's Johnny. I'm an
you want to leave it
here at Stony Brook. I'm just going to pop in and out kind of throughout the different sessions just to try and help answer any questions. If you got issues,
Okay.
That's great.
Reach out. I'm pretty.
Thank you so much.
You want to listen to this with me?
Andreas Koenig. I'm the director of the EVH major. And yeah, well, I'm waiting to see who shows up.
Sure. Sounds good.
So just warning you right now, guys, you're not muted, so everyone is hearing what you're saying.
Yeah, bye.
Does that, so you're not muted, so everyone's hearing what you guys are saying. Just be cautious on what you say. Now I'm going to unmute you guys again. So I unmuted you guys for a moment in case before we start you have any urgent questions. Anybody have?
Hello, everyone. Good morning.
Good morning.
I'm the director of the Globalization Studies and International Relations program. Welcome to this virtual Admitted Student Day. We'll be shortly the director of the International Globalization Institute, my colleague, Dr. Sophie Leroy. And
Okay, so I've remuted. Can you guys hear me? I've muted you all. Okay, so it is now, let's see, 11 o'clock, and I'm going to allow you to unmute yourself. I think we're going to do it that way. All participants can unmute themselves. Yes, we're going to do that right now. So you guys have freedom now to unmute yourself and ask questions. Is anybody hearing me?
Yep.
Yeah.
Excellent, great.
We hear you.
Back from another session, so I think we'll just go ahead and leave it this way that you're allowed to unmute yourself. Does that sound great?
Okay.
Yeah.
Okay, good. So guys, it's now, let's see, it's 11 o'clock, so I know you've got other things to do. So I'm Professor Hanna Nekvasil from the Department of Geosciences. And many of you have never even heard of geosciences. What does that mean? We're going to talk a little bit about many things today, and it'll become clear that a lot of the terms that I'm going to use are not something that you may have heard of, which is the whole point. At university, you get exposed to a lot more than you did in high school. So this session is on becoming a scientist, and becoming a scientist is a path. It's not something that you get just by getting a degree. It is something that you have to work towards from the very first moment you get into a university. So we're going to talk about what the path is, and we're going to talk about what you should be looking for as you make your selections for universities. So I have many goals for this. My top priority is for you to take back with you a set of information on wherever you end up going, you can call upon to maximize your experience as an undergraduate and therefore be able to become a scientist. The second goal is to get you to start thinking about your new role in life. You're stepping away from your parents dictating everything you do and you fighting it every step of the way to you having to make your own decisions. And that is actually a scary thing because making your own decisions, for most of you, your parents are footing the bill. So these decisions are affecting your parents, not just you. And part of what I'm trying to get you to do is to have your eyes open as you go through the process of selecting the university you want to join for the next 4 years. And those of you that are thinking, well, you know what, I'm not sure, maybe I should start at community college before I do this. So there's a lot of things I want you to be thinking about. We're going to look at costs of universities as part of the decision-making process, what you're exposed to at the university as part of the decision-making process. And so I'm directing this mainly to the students, but hopefully there are parents around also that can help address some of the concerns. You all know that we're in a very bad time right now for many people when it comes to their financial status at home. So the comments I'm going to talk to you about the costs of universities, how you need to think about it, is not just for the students. You students have to be thinking not just of yourselves, but is the cost of what you're taking on going to be affecting your parents? Many people at this point don't know if they're going to be laid off. Many people don't know what costs are going to be occurring at the university. And you guys have to be thinking that if you put your parents into a bad financial state, that's going to come back to haunt you, because who's going to help take care of them, of course, when the time comes that they don't have enough money saved away for their retirement. So you guys are now adults that you have to be thinking of the whole picture, what you want, as well as what is good for your family. And your family right now means you acting as adults for your parents. So with that introduction, I'm going to unmute you for a minute and see if there are any questions before we proceed.
No, I don't. Like, why?
Or we could put that there.
Okay, so right now we're hearing discussions among family members. Anybody on this site wants to say anything? Yep. Okay, I'll go ahead and mute you all now again.
Yeah, I like that. Yeah.
Okay, so I'm going to go back to that. Okay, so let's move on here, folks, and look at one of the big questions, of course, we have right now is how do you become a scientist? And that's what we're going to be going through as the first part of the goal is to get you to understand what you need to do to take that important step. So first of all, what does being a scientist mean? What it means is that you have developed the tools to be able to conduct independent research. This is not people telling you what to do, but for you deciding, can you pose a new question that has not yet been asked? Can you develop a plan to answer those questions? Can you implement that plan? And can you report the results? So these are the 4 important skills that you are working towards in your undergraduate degree. So what kind of training do you need for that? Well, the obvious kind of training you need first and foremost is you need to get the background. And that is the background in the field of choice. You all need a vocabulary. You need to be able to talk to each other, and therefore you need the same background. You can't identify new problems unless you have the background. The next thing you need is you need exposure to scientific thinking. If you're never around a scientist, how do you have any idea about how to think scientifically? And the third in here is you need a chance to be exposed to research, that is, being actively engaged in research. And now you see this last part is particularly problematic at a small university because many small universities don't have the facilities to allow you to be engaged in cutting edge, that is, the newest research out there. How can you develop new questions if you're only exposed to projects that professors are sort of jerry-rigging together for you to do, where you're not really engaged in real research? So you really want to be engaged in research that is current, that is with professors who have current money from NASA, NSF, NIH. That's what you're looking for, and that's not what you're going to get at a small university. This exposure to scientific thinking, again, you don't necessarily want to hear only what Einstein was thinking about. You want to know what the current scientific thinking is. What are the big problems right now that scientists are working on? So these are the things you're going to be looking for to get training, and you're asking yourself as you're choosing your college or university, can I get that kind of information and become a scientist? So one of the most important ways of guaranteeing that you can get this is to go to a research university. This is therefore not a 4-year teaching college, but a primary university that engages in research. So the most important reasons, the pros for attending a research university, is that you get exposed to a diversity of fields. A big university, of course, you have a lot more fields of people doing research. You have more research opportunities with the newest facilities. You have professors who are actually teaching your undergraduate classes as well as graduate classes and are active researchers. And through them, through this exposure, you will have access to the top graduate schools, because becoming a scientist for the future generally requires that you go for more than just a bachelor's degree. So your undergraduate degree is preparing you to get accepted to the top graduate schools. And this reminds me, I recently wrote a recommendation for a student who was exactly like you guys, was in one with this lecture and was deciding which research university to go to, and decided on Stony Brook. He actually decided to major in geosciences because he knew he could work on a lot of planetary missions right now, and he chose to work on some of the Mars missions. And now has his pick of grad school. So he was telling me all about his visits, his acceptance to all these grad schools, and he ended up turning down places like Princeton because he wanted to work specifically on the newest Mars mission, the Perseverance mission. So he ended up choosing Purdue as his graduate school because he's going to work on the newest missions. So this is what I'm talking about. You know, this is allowing you to consider, what do I need to get in that state to be able to get to the best graduate schools in the country? Okay, so there are definitely, sorry, I'm going to go back. There are definitely cons. What are the cons of a research university? The cons are that there are larger classes. A big university has a larger student body and you have larger classes. The other thing to remember is the professors that you have, as long as they're not adjunct, but they're actually full professors, you know, that is faculty in the tenure track at a university, they are wearing multiple hats. Yes, teaching is important to them, but research is at least as important, if not more important for them, which means that you are at least sharing their priorities. That doesn't mean that all the classes are going to be poorly taught. Many of us get excellent recommendations by our students. But what it just means is that you are being taught by some of the best researchers in the world, some of whom are not going to have English as their native language. We don't discriminate on the basis of where they come from. So if it so happens that you're the best person in a certain field happens to be French, then that may be that person's native language. They're still teaching it to you in English, but it does require you to understand you may make a little bit more effort in some of your classes. And then the next thing a big research university requires, particularly one that's a public university, because it costs so much less that you don't have somebody holding your hand, is you have to show independent drive, because there are multiple possible pathways and you have to decide what you want and you have to go after it. And that's one of the things that this lecture is trying to get you to understand is, how do you go about figuring out how to take advantage of a big research university without someone saying, okay, now do this, then do that, then do the following. So you need to show independence. And this is what I mean. You're now at a big research university, you will have to show a lot more independence and go for help. That doesn't mean the help isn't out there, but no one is going to come to your dorm and say, hey, you haven't gone to see your advisor. Go now. They're going to give you some emails saying, make sure you go see an advisor, and it's up to you to act upon that. So that's what I mean about independent drive. So we're going to work on that. So there are many research universities. What should you be looking for in a research university? Because many of you have been accepted to multiple of them and you're trying to figure out, how do I choose? So that what we need to do is start thinking about quality. What percentage of students get professional employment after graduation? What percentage get into the top professional schools and the top graduate schools? For many of you, for example, if you want to major in physics, how many of the students who major in physics get into those top research universities for their PhDs? These are what you're trying to assess while you quality. These are kind of questions you're going to be asking as you're making that choice. And fortunately for you, a lot of quality assessment is already out there. If you look at the U.S. News and World Report, and we're going to be talking about that, you're going to see that they have looked at some of the quality. They have ranked universities according to discipline. And although that's not the full idea of it, it does give you an idea of, and those things are usually ranked based on their graduate schools, not on their undergraduates. You're trying to see, can your undergraduate preparation get you into those top graduate schools? So this is what we mean by quality. So continuing further, I want to look for, you want the quality of the grad school programs, because that's what you're going to want to get prepared for. So you want to know, will you have access to professors that you could work with who have students who are top-rated students who chose your research university because they know the professor is so excellent? Because frankly, for most of you, you're going to be working very closely with the grad students, and you're going to get a lot of education by working with them. So you're going to want to be looking at are these professors the top in the world? And these professors being top in the world does not mean they're all going to be at Princeton. Many of them, for example, are at Stony Brook and at other public universities because they are around like-minded professors who they happen to work with closely in their fields. So we already talked about this quality. Let's move on to the cost. Remember, when you are buying anything, you look for quality, but another important factor is, what can you afford? I mean, you know, some of you may feel their Lamborghini is your dream car and you think it's high quality, but if you can't afford it, it doesn't do you any good. So you want to get the best quality for what you can afford. So again, students, you've got to be asking questions. How can you afford your university of choice? And I'm going to tell you one of the most important two things you need to be thinking about is, one, do you need to take out loans? Because I tell you right now, a loan is really not financial aid. A loan is mortgaging your future. So do not think of loans as financial aid. Think of banks laughing all the way to your signature for what may be the next 30 years. So you want to, as much as possible, not take out loans. So if a university says that, okay, great, we're going to give you $10,000 in gift, so as a grant, and the rest we're going to do you $30,000 in loan, and look, then you'll be able to meet your financial obligations. Don't think of that $30,000 as financial aid. It is something that will mortgage your future. Instead of buying a house, you're going to be paying off that loan, because those loans are going to keep accruing interest. You can't pay them right away. And remember, guys, you're all bright young people. Don't think that, okay, if I take out, $120,000 in loan and I start earning $60,000, then I'll be able to pay it off in 2 years. Folks, it does not work that way. Whatever you start earning, you're going to have to pay taxes, you're going to have to pay for your lodging, you're going to have to pay for car insurance, you're going to have to pay for food. So I guarantee you, even $120,000 in loan could take you many, many, many years to pay off. So please remember, you're now adults, help, and please remember another thing about loans. Your parents love you dearly. I can't imagine a single parent on this web talking to you today who doesn't think that you are the most fantastic thing. And they have done everything they can to give you what you want. And when you tell them, Mom, Dad, I got to go to Brown. I want to go to Brown. I want to go to Princeton. Oh, I got to go to Duke. I got to go to such and such, to UNC, Chapel Hill. Remember, it's very hard for them to say no. And therefore, you have to be part of this and ask yourself, if your parents or guardians help you pay for this, are they still going to meet their current and future expenses? So remember, before, they had to ask themselves, can I afford to buy you a car and still be able to pay my taxes, my mortgage, etc.? Now you are becoming adults. You are asking yourself, you're in a way becoming the guardian of your parents, because their desire is to give you everything you want. It is very hard for them to say, I cannot afford it. And I guarantee you there are many parents who have had to dip into their retirement income to pay for what their kids wanted. And it hits very home for me. My oldest brother did that for his oldest child. He dipped into his retirement so that his son could go to Embry-Brittle and follow his dream of becoming a pilot, which means that he now cannot afford to retire. So these are, again, why did he do that? Because his son begged, please, please, please. It turns out there were other ways of doing it, other very good schools, but the begging is what did that, and it was not good for anybody involved. So let me continue. So what does that mean for you? It means that you need to be aware of three important things. There are three primary types of colleges, and by this I mean universities too. Public universities and colleges, private nonprofit colleges and universities, and for-profit colleges, universities. For-profit is what you want to avoid at all costs. These are geared to try and remove your money out of your pockets. So borrowers on average pay a lot more for and there are very few for-profit colleges who ever rise up into the ranks of quality that, for example, the U.S. News and World Report has ranked. So look very carefully to find out if what you want to apply to is a for-profit college. So mainly what it leaves are public colleges and private. And private nonprofit universities tend to give the students a lot more loans and they come out owing a lot more. Public universities tend to be a lot less costly, and therefore the amount of loans tend to be less that students have to take. And many students work in addition and they're able to pay some of their expenses. So these are the two types of colleges for you to consider. And to give you an example, Stony Brook University is a public university. University of Pennsylvania is a private nonprofit university, as is Rensselaer Polytechnical Institute, as is Yale, etc. So be aware that there will be a huge cost. So a lot of you are saying, okay, but are the public universities as good as the private ones? And that's what we're going to be looking at next. So we're going to look at U.S. News and World Report. The newest rankings 2019 haven't come out yet, so we're looking at the 2018 U.S. News and World Report rankings. Notice the rankings here. This is for Stony Brook's nuclear physics. Remember, we're ranking graduate programs because you will be, as part of your training for your research in the future, you're going to be doing research and you're going to be working with professors who are in these ranked departments. So for example, nuclear physics is ranked 3rd in the country. Overall physics, 23rd in the country. So let's give some examples. That is above Brown University, above Purdue University, above RPI. So these are all private universities that they ranked above. Why would anyone who wants to major in physics pay Brown tuition and take out all those loans when they could come to Stony Brook and be in one of the best departments at Stony Brook prices? Okay, what are Stony Brook prices? So here are the prices of Brown, Purdue, which is has a lower price because it's partly supported by its state, and RPI, when you could instead be attending Stony Brook at a cost of $10,756 per year. This is tuition and fees only. This is not dorms. And giving you an idea of, for that price, this is the annual tuition and fees, you could be getting a department that is ranked 3rd in nuclear physics and 23rd overall. So this is what I mean about you having to assess what is quality? What does quality mean versus what your financial expenses are? Even right now, if you were independently wealthy and could afford to go to Brown, why would you go to Brown to major in physics if you can spend that much less at Stony Brook and get a better program? So this is what I mean about why you have to ask yourself, what am I really paying for? Okay, let's look at chemistry. Some of you have asked about chemistry. And again, we're going to look at the chemistry ranking 2018, U.S. News and World Report, ranked at 53rd in the country. There are a huge number of chemistry departments. So that's really outstanding. And again, it's above Brown, it's above Dartmouth, it's above Brandeis. And look at the price tags of these universities that it's above. And you ask yourself, why would I go to a lower ranked university when I could get fantastic chemistry at Stony Brook? And I just, for Brown University, give you an idea of how much the overall cost is. First year of attendance at Brown is $80,000. Now, if you got $80,000 lying around and you want to major in something other than chemistry, or then you could go ahead and go to Brown. But just ask yourself, is this really what you want to be spending your money on as you're going through the quality questions? Geoscience is my field. It's ranked, I can't see the exact position of it, but it's ranked 38. There we are. Okay, and so let's look at what it's above. It's above BU, for example. It's above Dartmouth. It's above University of Pennsylvania. And again, look at the price tags. And what you could get instead is at the cost of Stony Brook. So I'm asking you to think very carefully about finances and what you're getting for your money. So those of you who are interested in biochemistry and cell biology, for example, here is the rankings of 54. It's equal in ranking to Brandeis, University of Southern California. It's above Boston University. And again, look at the price tags that we're dealing with for that. So again, I think that's it for looking at that. Let's go on to asking ourselves, some of you are saying, well, okay, I never wanted to go to one of those schools because I knew I couldn't afford it. I was going to go to a SUNY school. And oops, I live on Long Island. I really don't want to go to a Long Island school. And look, guys, at what you're missing. So let's say you want to major in science at University of Buffalo. You're going to be at a much lower ranked school, and an average annual cost is higher than Stony Brook. And look at your starting salary. Your starting salary is lower if you have an education in science at the University of Buffalo. Look at Geneseo. Some of you say, oh, I want to go to Geneseo. I got in. It's so competitive. It's great. It'll cost you more, most likely, and your earning power will be that much less. So asking yourself these kinds of questions. A great website that was started during the Obama era is collegescorecard.ed.gov at the bottom of this. And this is showing that, hey, back then there was great concern that people knew what they were getting. You go out, you buy a car, you test drive it, you do research on it. A lot of people are entering colleges saying, oh, I just don't want to go away. If you don't want to live at home, then go and live on campus. And your life will be much cheaper for you, and you will be getting a better education. So what I also pulled out for you is some of the local schools. Pardon me, I went too far. Okay, look at Syracuse. These are some of the New York schools that some of you may be asking for. Oh, Syracuse, I want to go to Syracuse. I want to go to Barnard. I want to go to NYU. So again, after financial aid, this is how much you'd be paying as opposed to after financial aid at Stony Brook. And notice that there's almost no difference between all that tuition you'd be paying and the difference in the starting salary. And this starting salary, 55, is including all the people that are majoring in history and English and other lower paying fields. So you should be really proud that it would be a university for you to think about in terms of the quality. So I think that's, let's move on and ask ourselves, what else do you have to look for? So cost and quality. But guys, all the cost and quality in the world is no good if you as an undergraduate don't have access to the research. Let me give you an example. There was an article a few years ago, maybe about 3 years ago, in the paper that was about how upset Harvard science students were. Because they went to a great university, they had great credentials, and they found that they never, when they did research, they never met their professor. They were only meeting the graduate students that they worked with. So when it came time for writing recommendations for graduate school, no graduate school wants to hear from a graduate student. They want to hear from the professor who was in charge of the lab. These students couldn't get recommendations from the professor because they never met the professor. So what you want is an undergraduate-friendly university. A undergraduate-friendly means that you can pretty much get into anyone's lab. You can go over to the medical school and do research there even as an undergrad. You can go to the engineering school and do research in labs. You can go into working with people who are working on the Mars missions or the lunar orbiters, etc. That's what you want, is you want access to a research university's research. So here is an example of wanting to be able to be in labs. You want to be able to become a scientist by working in the labs themselves. Okay, so what is the path? The very first path is you've got to select courses and a major. So let's look at that in more detail. So the second thing before we're going to discuss after that is choosing a research mentor. How do you go about doing that? And the third thing is being able to present your research. So this is the path that you want to take at a research university. So step one, as soon as you enter your freshman year, you need to start getting those basic science and mathematics courses out of the way. Folks, this is not necessarily the time to choose the major. You can assume that any science you choose, you're going to need to take calculus, you're going to need to take freshman chemistry, you're going to need to take freshman physics, and maybe freshman biology. Why do I say, I'm saying that is because I have had so many students tell me, oh, I hate chemistry. I'm never going to major in chemistry. And I tell you, you don't know what chemistry is. You think you know. You may have had a horrible time in your AP chemistry in college, in high school, but that's just the basic stuff. That's the background. That's not real chemistry. Nobody's doing that stuff in research. That's the vocabulary you have learned. Many professors in chemistry didn't like freshman chemistry. So I'm asking you for your forbearance. Ask yourself, give yourself a try. Look at what chemistry really is. Now, some of you say, oh, I hated chemistry. I got AP credit for chemistry, and I'm out of it. And my point to you is that if you do end up choosing like biochemistry or environmental chemistry or really want to get involved in synthesis of the newest materials that have never been made before, and you want to be at that cutting edge, you need to know chemistry. And the AP courses are not the same as university level courses. So my recommendation for you to consider the following is, any access to research and access to graduate school requires you to have a good GPA. Don't kill your GPA by saying, oh, I took AP chemistry, I did really well, I'm going to go straight into organic chemistry at Stony Brook. You could, because you'll get credit for it. But what does that mean? That means you're going to be behind the students that took the Stony Brook chemistry. And you're going to be struggling that much more and are more likely not to do well. And that will be the beginning of a GPA that is less than perfect. Instead, if you said, okay, I want to hold out the options of doing something in chemistry, so I'm only going to accept one semester of chemistry. I'm going to go into the second semester of freshman chemistry. So maybe I can get an A in it, and I'm going to wow the professor, and I'm going to get my GPA up really high. These are the considerations I want you to think about. If you say, I'm going to major in bio, and I'm never going to take a biochemistry course, then go ahead and accept those AP credits. Or if you come from a community college, again, go and accept the community college credits. But I guarantee you one of the biggest problems we have is people getting credit from community colleges, coming to Stony Brook, and then falling flat on their faces. This is particularly true for math. They get their calculus, and then they come into Calc 3 at Stony Brook, and suddenly it's like a different planet. So please, guys, you could get some credits, but ask yourselves, is it wise to throw yourself into the next level without ever having the chance to get the background that the other people who are starting at their freshman year are getting? And I'm not telling you not to. Some of you may know, I found AP chemistry so easy, AP math so easy. I have no problem. I'm not going to have a problem going on to the next one. But if you struggled at all, then reconsider carefully what credits you want to accept. And remember, you're the ones that ask your AP scores to be sent to the university. So you're the ones that decide what it is that you want to get credit for and what you want to start with. Okay, so let's go on to choosing a research, okay, selecting a major. So we're going to go on to that. How does one go and select a major? Sorry, I think I'm going back. Pardon me for a second. I'm on this very sensitive little wheel here. So now we're going to go and select that magic field of science, folks. This, I cannot tell you often enough, that science is not what you think it is. Many of you, well, all of you will have come from high school. And as you've come from high school, you think that science is physics, chemistry, biology. I guarantee you that science is much, much more than that. Take even, for example, my field of geosciences. This geoscience as an example. It covers all of them. People who are interested in physics study geoscience. People who are interested in biology study geoscience, and particularly astrobiology. People who are interested in chemistry study geoscience. So this is just one example of interdisciplinary fields. There are many, many fields of science that you've never even heard of and that you've never even dreamed of could cover the things that you're interested in. So before we go into that, just to remind you, if you think you might like applied science, you want to make things, the questions you're interested in asking are all related to, wow, can I make the next best batteries? Can I make the next type of energy efficient equipment? Please do not forget, you do not enter an engineering program initially, you apply into it. So any of you guys who are interested in science can switch to engineering. Don't feel that your path is taken right now. So your path is still open as you enter in your freshman year to go into science or going into engineering. So the first way I'm going to ask you to think about choosing a major is not by thinking about, oh, I like chemistry, I like physics. I want you to actually go to the university's website and go to the chemistry department's website and the physics and the chemistry and the biology and look up the tab that says research. Because that is what is being conducted at the university. That is your goal of getting exposed to. That's telling you what the hot fields are right now in that field of science. And you're going to find things are very different than what you thought. So there's a lot of websites that you can look up. Here is a listing of all the things: anthropology, biochemistry, ecology, evolution, neurobiology, etc. See, there are all the fields of sciences and arts in the College of Arts and Sciences, and there are lots of fields of science in School of Marine and Atmospheric Science. And as I said before, remember, you can still apply into engineering after the freshman year and look at all the different fields there are here. Some are very similar to what you get in science, like material science and engineering, and some are more classic engineering that you think of, like building bridges. But so why am I asking you to go to these fields? Because I want you to look at what excites you. What are the questions that the professors are asking that excites you? Don't think chemistry is just chemistry, physics is just physics, biology is just. So here's an example. Let us say you want to study planetary science, that you want to become part of NASA's Perseverance rover team. Remember, that's the newest rover that's scheduled to land this summer on Mars. You want, as an undergrad, to be part of the team that decides where to go, what samples to collect, looking at the rover. Well, okay, so the question is, what should you major in? Some of you might say, well, that's easy. I'm going to major in astronomy. You can major in astronomy, and guess what? You'll never be able to, with that major, get on the Perseverance rover team. That NASA team is not interested in people who've studied astronomy. They want you to have studied something very different. What is that? They want you to know geoscience, to understand planetary science, because what are they looking at? When they land on Mars, as they have, the rover is roving around a solid planet. They don't care about astrophysics. They care about what is that material on the surface. So you would be wrong if that is your dream. You don't major in astronomy. You major in geoscience. Let's continue our exploration. Okay, guys, Let us see if you're really interested in chemistry and how large molecules interact to give a certain effect in a living organism. Let's say its ability to photosynthesize. What kinds of organization of large molecules would allow, for example, a cell to be able to produce energy through photosynthesis? So a lot of you would listen to that and go, wow, that's really neat to be able to figure out, what if I can actually make something like that? What if I would actually be able to engineer cells to do certain things, like make certain antibodies against the COVID-19 virus, like to make certain, to change damage to DNA? Wouldn't that be really awesome? A lot of you would say, well, that's easy. I got a major in biochemistry. And you could certainly, having a good background in biochemistry would be great. But look at where this kind of research is being done, guys. In the Department of Applied Mathematics and Statistics. So this is why you can't just assume that that you know what a field is. You've got to go look. Let's take another one. Let's say you're interested in how pollutants affect biological communities. Again, you would look at this and go, hey, maybe I should major in biology for something like this. Well, who's doing hot research in this right now? Are people in the Department of Ecology and Evolution, not the Department of Biology. This is why you've got to look on these research sites. Let's use our last one here as an example. Okay, let's say you want to do energy of the future. Can we use thin films for making photocatalysis? Many of you would have said chemistry, but as you can see down below, it's the Department of Physics. So my point being here is you need to go onto the university website to the fundamental sciences that you've heard of, the fundamental sciences, chemistry, biology, physics, engineering, and look at the research tab and find out what excites you. What do you think is the coolest thing ever? And then you ask a question. You reach out, you email that professor who has doing the research and ask to meet that professor and ask them a very simple question. You can do by email. What major and what courses will be best to prepare me for this kind of work in the future? And they may tell you what to major in. And you see, for example, any of those questions, they would say, okay, I want you to major in applied math, or I want you to major in physics, not major in what you thought would be the case. Or they may say the best way to do this is have a double major in a double background in, for example, geoscience and computer science. So that's what you want to learn about early on. Don't make these decisions without thinking. Then go to another professor, find a second thing that really interests you and ask the same question. And eventually you'll start identifying what your interests are and the common pattern of those interests that you see. So let's go and say that you finally decided you're going to major, double major, let's say, in marine sciences and chemistry. Or you're going to major only in geoscience or only in applied math. You now are going to do something that you may not be aware of. You as an undergraduate will have two advisors no matter what university you go to. You will have a regular undergraduate advisor who helps you get through the university's requirements, those courses like writing, the history courses, the global courses, the language courses. But you also will have an undergraduate program director in the major you're interested in who will help guide you through what are the major courses, let's say in physics. What are the physics courses you should take? Should you be taking honors physics or should you be taking the slower sequence? These are all incredibly important for someone to help you with, and the regular undergraduate director will not be able to help you with this. This is only something that your major program advisor will help you. So be very important in step 4. So now let's move on to step 5. So reach out again to the professor. that you reached out before and said, hey, I've majored in what you suggested. Are there any specific elective classes I should take before you will take me on as a research student? So again, you are giving a good faith effort to prepare yourself. This is where your drive comes in. You are preparing yourself for research, and you have told the professor, I am preparing you. For example, I have freshmen coming to me and saying, I want to do research with you. And I tell them, but you don't have the background to do research with me. And instead, I have other students who say, you know, I major in geoscience. I've taken these courses. I really want to do research with you. What is the course you want me to take before you can accept me on? And I tell them, I want you to take Geo 407. And if you do well in it, you're going to have a fantastic research project that will help us figure out the hottest new research about what kind of minerals we expect to find on Mars. And you will be able to go to graduate school from that. You see, because that student has done their due diligence and prepared themselves for what I can offer them. So this is what I mean. You reach out once you've decided you really found something you're very excited to work on. So, and then you will be invited into that professor's research group. You will work with grad students, and at a place like Stony Brook, you will work with a professor also, and you're going to get excited because guess what, folks? You're going to be part of a team. You, as an undergraduate, will be playing an invaluable role being part of that team. And that is what we mean about a real research experience. You're not going to be washing dishes as at many universities. You will actually be engaged in, how do I pose the questions? How do I develop a plan to solve those questions and be part of it? And many of our undergraduate students present at conferences. They write papers with their advisors. So you then will be able to present your research, and through doing so, you have best prepared yourself for the life of a scientist and to be accepted into the best graduate programs into the country. So I'm going to end at this point, and please selectively unmute yourself to ask questions. Okay, I'm going to unmute, and I'm going to unmute. Does anybody here, I'm going to unmute here selectively to see if any of you, any questions?
I did not have any space to draw. Don't worry about it, draw something else. You don't have to
Okay, so are there any questions?
Someone in the chat asked, how long do these projects last, and how can we know they still exist by the time we enter school?
Okay, so you mean the research project by the time you enter graduate school? Is that
I'm not sure. Someone else asked this in the group chat.
Okay, so yes, I do see some chat questions here. I can open. So,
Bro, she unmuted everybody. The professor is not tech savvy.
I'm going to mute people for a moment, and I'll answer the question. So, folks, normally what happens is this. Many people start doing their research in their junior year, and they often stay with the same research group for 2 years, and sometimes they even get money to stay at the university in the summer to do their research. We often do that, for example, take NASA funds, and the students earn about $8,000 while they're doing research, for example, in my lab and in the NASA run labs. So that means that's what you want to prepare for. You want to prepare for starting this in at least the second semester of your junior year. And some of you who come in with a lot of AP courses may start it sooner. But remember, you're best posed to take advantage of it if you get some of the background first. So yes, I see the questions. Does that help? Let's see what other questions they are. Okay, so here we go. Here's another question. Having such a large facility, are research opportunities limited? Folks, this is a really important question. The answer is yes and no. if you choose to be one of the 2,000 majors in bio, how much research opportunities will you have? If you choose to be a major in geoscience, you will, just about everybody has to do research. The same for physics. Many have the chance in chemistry, many in marine sciences. So the bigger major, the less the chance. That doesn't mean that you can't have a chance, particularly if you reach out to the press and you tell the professor that you've looked at their research, you really want them. That will make a big difference for you rather than just an unknown person looking at that. So does that help? I'm going to unmute. Let's see what else, what other questions. I'm going to go back to unmuting you in a minute. So anyway, somebody asks if Stony Brook is a good research facility. Again, you saw the rankings, and those rankings are for graduate programs, which means it's totally based on research performance. So that's excellent. And guys, just to remind you who are interested in health science and maybe going on to medical school, I want to mention this because we always have people who decide, well, I have to either go to medical school or do science. No, to be pre-med is a set of courses. It's not a major. You can still major in any science you want, which gives you the chance, if you don't get into med school, to still continue on in grad school. Let me give you an idea for my own, one of my own children. One of my daughters was here in high school. She took some of the Calc 3, 4 and the honors physics, and then she went on to Yale to double major in physics and in molecular biophysics and biochemistry. And then she went on to medical school. She's doing a PhD and an MD, which means that they pay at Harvard, they are paying for her medical school and paying her $32,000 a year plus free tuition. So that's called the MD PhD program. How do you get into those? You get into those by not majoring necessarily in biology, but majoring in something where you stand out. Her majoring in physics made a huge difference to her application because she got to know the professors, she got to do research with professors, and it made the medical school stand up and say, hey, you're not just another of those 100,000 bio majors. So this is really important for you guys to figure out. Don't shortchange your interests and say, oh, I got to major in bio if I want to think about medical school. So I think, let's see if there's anything up. Let me go ahead and unmute and see if there are any questions. Okay, I just unmuted all. Okay, unmute. Okay, so you guys should be free to unmute yourself if you have any questions at this point.
Could you discuss research opportunities in pre-health or pre-medical paths?
Okay, so for folks, I'm going to again mute you all just so we don't get background noise. So folks, pre-health, there are many, many pre-health programs, and some of them like physical therapy, pre-dental, et cetera, dental hygienist, et cetera. There you have a prescribed set of courses, and it's really hard to get engaged in research in those. So it's more the medical school, dental school that those applicants really, they want to see that you've done research. And the same thing holds. You find out who's doing research you're interested in, and you contact the professor directly. You don't have to worry about, oh, is there a form I fill out? You literally say, wow, this professor is doing really neat stuff and do exactly what I said. So you're not excluded if you're going to be in the PT program from doing research, but the problem is many of these programs have a very tight path for you to get your certification, and therefore you simply may not have the time to do that. So I hope that answered your question in that. I'm going to unmute again. So
3, 4, 5, 6, 7 years ago, we were talking about Facebook. What does that mean? I need you to be more
that's
specific.
somebody else. I'm going to let you selectively unmute yourselves, guys.
All right.
Any other questions?
Up to you.
What majors do you think stand out when it comes to applying to MD, PhD programs?
I have
Okay, I think
very little
what you
idea
really
what
want to
you're talking
consider
about.
doing
Like those
is
decisions
doing
you
something
talk
like
about.
math, like physics,
Right. Sure.
even
Like that.
geoscience,
You can explain
as well as double majoring in biochemistry. So that's what my daughter did.
the
She's
question
on
first.
she's right now at Harvard on the team that selects for
Okay.
students in the
We'll
MD
talk
PhD
about
program. And she says a lot of engineers, a lot of applied math, a lot of physics, a lot of people who are doing chemistry, but not just biochemistry. People, for example, who are interested in physical chemistry. All of these kinds of things are what really stands up to take notice. You will still need to take your pre-med classes. That's not a problem. Everybody has to do that. Do you realize that Harvard's med school and MD PhD program even accepts history majors? That's how they really want to be out of the
やっぱ
box.
りこういうの子供ってエリートなのね。わかる。
I'm going to mute all again at some of the chatter. And now I am going to allow you to unmute yourself. Okay, and I'm going to
アメリカンスクール小興味あるのね。
Okay, I'm going to go to the chat right now, and I don't see anybody asking a question, and I'll continue.
Very helpful, thank you.
Okay, great. So I want to thank you guys all for this. I don't even know what time it is right now. It's 11:55, so perfect timing here. There is a counselor online, Jonathan Grimmer is here, and he can continue chatting and help ask questions. And I looked up, and it looks like we've managed to answer everybody's questions at this moment. Am I right? Is that it for everybody? No last questions?
I actually had a question.
Okay.
I wrote it in the chat earlier, but I guess it got skipped over.
Can you speak a little bit louder?
Close to Brookhaven Lab, I was wondering what the likelihood of doing a large-scale project, possibly branching over with Brookhaven would be. Like, what's that likelihood as?
What an excellent question. I'm going to again mute you guys so we don't get the chatter. So the question was, Brookhaven National Lab, which is part of Stony Brook, has the cyclotron, and what it does is a huge amount of research is going on there. And I'm just getting, again, my department alone, because my department, I know the best. We have so many professors with so many undergraduate students working at Brookhaven, and they also continue working in the summer. There's a lot of paid research that continues in the summer. We have a bus that goes to Brookhaven for the students who don't have car access. This is an integral part of research, whether you major in physics, whether you do chemistry, geoscience, marine science, there are all, and if you do material science, all of those have, many of them have projects at Brookhaven, and many students take advantage of that. So again, that's something that Stony Brook is really unique at in providing that opportunity. All that looks great for graduate schools, all that looks great for professional schools. So did that help? Was that helpful?
Yes, but I was just wondering, is it, like, how likely is it to communicate that, like, how easy is it to find a professor that is doing that type of research versus one that's simply doing research through the university?
Okay, so again, I'm going to mute all, and then, so again, that's why you go to the research tab on the department's website. Let's say you're interested in physics. You go to the research tab, you go to the department website on physics, there'll be a research tab, and there will be every professor listed and about a paragraph on the research they're doing. And so that's why I want you to go down and you read through and you find out who's doing research at Brookhaven National Lab. For example, in our department, Professor Lars Aim and is an example of someone who is actively developing brand new high pressure materials and looking at the interior of the earth at Brookhaven National Lab, doing experiments like that. So it's on everybody's research page if they're working on that.
Thank you.
You're welcome. I'm going to unmute all to see if there's any other questions.
Question. So,
Sure.
like, how many undergraduates, like, get accepted to medical school? Like what percentage?
みんなメディカルスクール興味あるのね。
Yeah, so that is something I wouldn't be able to answer, but there maybe in the health sciences when they medical school. So I couldn't answer that. One of the other sessions might be able to, there's a pre-med section, I'm sure, that will talk about that.
My question was if you could reiterate which major your daughter was who got into the Harvard MD PhD program and describe what that major or double major entails.
Absolutely. So my daughter majored in, at Yale was called intensive physics. And so she took all of the regular physics classes like a regular physics major, and she did research in physics on her first, when she first started doing physics. But she also, the second major was called molecular biophysics and biochemistry. And in addition, she took a lot of chemistry courses. She took organic chemistry, she took physical chemistry, and she did a combination of biochemistry research, which was mainly experimentally based. So what she was really interested in is making new biomaterials. So that was sort of a combination of her physics research and biochemistry. And that's what got the MD PhD program most excited was that she got recommendations from both the biophysics mentor and her physics mentor, because she did 2 research projects, one in each department. So did that help?
Yes, thank you so much.
You bet. Any other questions?
Just out of curiosity, what school was that? Because this seems like a lot of research opportunities for her.
Well, she started her research at Stony Brook, believe it or not. She started research at high school here at Stony Brook in the physics department. And then she went to Yale. And that's where she did her research, the rest of that at Yale. But she started here at Stony Brook, high school.
だから自分の娘生かしてんのね。
I'm sorry, I couldn't hear. Somebody else have a question?
I have a question. So if I want to do pre-med, would I have to start in my freshman year of college?
So there will be a pre-med advising session, and let's see if we have, who is our undergrad advisor here? So anyway, well, hold on, I'm gonna look, see if I can find our, it's Jonathan. Jonathan, are you there? But anyway, he may not be online anymore. There will be a pre-med advising session that's listed on the programs for the admitted student day. Be sure to go to that and they will tell you all about it.
Okay, thank you.
You're welcome. Any other questions?
No, thank you.
Okay, I want to thank you guys all and good luck, and remember to think carefully about your family situation. Think carefully about the opportunities you want, and I wish you the absolute best and stay safe. Take care.
Thank you so much. Have a good day.
Thank you. Bye-bye.
Have a good day.
Thank you. Have a good weekend.
Thank you. Bye-bye.
もしかしてママのも聞こえてたのか。